Hello, and welcome to this Math is Everywhere podcast. We often fail to appreciate how much of a pre K child's life, and above all, their play, involves thinking about and working with sets of things. A set is any collection that is grouped together in some meaningful way. Sets are basic to children's thinking and learning. For very young children, such as Alex, some of their first thoughts around sets might be, "These are my dinosaurs, and those blocks belong to Imani." In order for children to learn the names of things, they have to be able to create sets in their mind, such as this is a set of pom-poms, or this is a set of buttons. Once children can organize items in a set, then they can count. Counting requires a set. And one of the most important jobs of each number is to describe how many things are in a set, be it 3, 12, 27, or even 200. Children's understanding of sets leads to enhancing their ability to think about and use not only sets, but also patterns and numbers, making math meaningful. Children who understand that attributes can be used to sort collections into sets demonstrate that they have developed a working knowledge of what a set is and how it is constructed. Young children need many math-rich experiences working with sets, including matching and sorting items, as well as combining, comparing, and ordering sets in different ways. Teachers support this through intentional conversations about useful ways to break a collection into sets. These experiences help them construct the ideas that are the foundation upon which competent and flexible counting can be built. Provide real and found items along with other classroom materials for children to manipulate. As children use the materials, encourage conversations about attributes. This one is big. These buttons match. They are the same shape, or these all look the same. As children begin to recognize attributes, encourage them to group like items. You have many opportunities during the day to encourage matching and sorting. Center time and cleanup time are packed with those opportunities for you to notice and comment on creating sets and sorting. You may notice as children work, you took the set of square blocks from the shelf, or you chose the basket with the set of pegs, and Kai chose the basket with dinosaurs. During cleanup time, you may note, you sorted the food that goes in the cabinet and the food that goes in the fridge. Or Hannah, you matched the shoes so you could put them up together as a pair on the dress-up shelf. Children begin the first step in organizing collections into sets by matching items that are fully alike. For example, in the activity Find My Match, you would begin by asking Alex to find the exact match to the red star. By keeping the variables, color, number, and shape limited, you are helping him stay focused on the problem and therefore increasing likelihood of success. This activity gives children the opportunity to receptively recognize a match before asking children to produce one. Once children are ready, you can make this simple task more complex by introducing more shapes and colors, or increase the number of items in the collection of the set, or take one away and figure out what is missing. Remember, sorting is different than matching because it involves reorganizing a whole collection or set into two or more subsets. Most children will typically begin by breaking a collection into two categories, focusing on one attribute. The mathematical term for this is binary sort because the children only produced two sets. Such as this example, all of these buttons are pink, the others are not. This activity is a great large-scale demonstration of how the process of sorting works and how this produces a set. This is a great large-scale demonstration of how the process of sorting works and how this produces a set. Start with 5 children and say, I see 5 children in front of me. Some have curly hair and will stand in this hoop. Some do not have curly hair and will stand in this hoop. Ask the children to sort themselves into whichever hoop describes them. Encourage children to talk about whether the set checks out. You will begin to hear children describe why different children moved into the hoop or the other hoop. You can also do this using other attributes. Children who wear glasses, children who do not wear glasses, children who wear sneakers versus children who wear boots. You could even use the color of their shirts. In this activity, What's My Rule? Have children separate a group of objects that share the same attribute from the rest of the collection that doesn't. Again, this game is focusing on receptive skills. You want children to recognize the rule used to establish the set. This is much more of a challenge than Find My Match. Talking to children about the rule of sorting helps solidify the concept in their mind as they think about making other sets from collections. Encourage children to sort everyday items in a variety of ways. This idea is super cute for dramatic play. Provide a divided plastic container and assorted cosmetic or bathroom items, such as cotton balls, Q-tips, small brushes, or Velcro curlers. Children can place like items in sections of the tray. Encourage them to verbalize the reasons they placed certain items together. They may say, these are all soft. These are all cottony. These are all spongy, or these only have sponges on the end. With practice and support, children begin to gain a deeper understanding of the relationship between sets and sorting, and the idea of a set becomes more flexible for them. Children will then move to sorts that involve more complex attributes that create more sets. Children need to be able to think about the different characteristics of single items. For example, this activity is called Pass the Rock. First, read a book about rocks, such as this one, Rocks, Hard, Soft, Smooth, and Rough by Natalie Roginski. Next, provide a basket of different rocks. Pass the basket around the group and have each child select a rock. Talk about the different textures. Are they hard? Are they soft? Are they smooth? Are they rough? Place hoops or carpet squares on the rug and have children work together to sort their rocks in different ways. Later, in a small group or during center time, offer children a basket of rocks to explore and sort in other ways as well. When children understand that rocks can be sorted by different attributes, they have learned something important about same and different, and that will help them become more abstract thinkers and problem solvers in math. Let's watch as this teacher does just this and listen to the unique way that this child sorts his rocks.
Tell me, how did you sort them?
Big, from big to medium to small.
So you sorted them by size. You put all the big ones in a line and you put them in order. So I'm going to mix them up all together and see if you can think a different way.
Okay.
You were sometimes
It makes it crazy.
Yeah, no, can you figure out another way to make them into groups? You were saying before that ones looked like a pancake, they were flat.
So this one is a flattish.
So
you put it with the flat, and this looks like a tooth.
I can see that.
This looks like a poo. That's poo. Dinosaur poo.
Mm-hmm.
And this one looks like the tooth. And these look like this is a flat pear cake. And this looks like a bumpy tooth.
Mm-hmm.
And this looks like a piece of poo. A splat poo.
Okay.
And this looks like a piece of smushed poo.
Okay.
This looks like a big, smooth piece of molded egg.
Oh, like a kind of an egg?
Yeah, a dead egg.
A dead egg.
This looks like a car. And this looks like a car. And this looks like a car.
Okay. So is this a different group or do these go together?
These don't go to
Oh, so
the.
this is one group and this is another group.
And this is another group. And this is another group. And this is another group.
Okay, so this was the flat group. This was the tooth group. This was the smushed egg group. This was the ones that look like a car.
Yeah,
Group.
and these are the poop group.
Here's another idea you can find on our website, Woozles. These fun Woozles cards encourage children to sort. As you play this with children, have them notice the attributes of the Woozles. Some are hairy, some are bald, some have dots, some have only one dot. Some are different shapes. You can use the plain white or the different colors to encourage children to sort in a variety of ways. As children are playing with the Woozles, use this matrix to record the different ways they sort. Offer books in your classroom that show ways for children to explore sorting, such as this one from Get Epic, Sort It Out by Barbara Mariconda. It's about Packy the Pack Rat who sorts his collections in all different ways. It's a great story to share with children to understand the many different ways Packy's collections of things can be sorted. Another great example is the book, A Pair of Socks. To extend this in your classroom, collect an assortment of socks in different colors, sizes, and textures. Use small laundry baskets to hold the socks or hang them up on a rope with clothespins similar to a clothesline. Encourage children to find matches for the socks and roll them together or hang them together. They can sort the socks into groups, all of the white ones, all of the striped ones, all of the long ones. Challenge the children by asking, how else can you sort the socks? Look for different and unique ways to sort. As soon as a set or collection is broken up into groups, children will begin to show a strong instinct to compare. Sometimes the comparison is about which is better or preferred. Isaac may say, I like oranges better than apples. Frequently, however, comparisons between sets focuses on quantity. Children are often concerned with questions such as, which is more? Which one is bigger? These comparisons are always about the three possible quantitative relationships between sets: more than, less than, equal to. By organizing things into groups, it makes it easier for young children to compare quantities. Children need meaningful opportunities to see how sorting a collection into sets makes it easier to compare quantities. How many of you have a pet? Sort, then count, just like this example using a simple question of the day. When quantities are equal or rather large, the only way for children to know which is more is to count. And before they can count, like in this example, count the coins, they must be able to sort into meaningful sets. In a math-rich environment, you recognize that questions will come up such as this and use that as a great teaching opportunity. As children become more competent at creating and manipulating sets, they are ready to sort and compare more complicated collections. Think about sorting shoes on a large grid, either in large or small group. Start with each child putting one shoe in the pile. Encourage children to identify several sets into which the entire group can be sorted. Have them compare quantities and order the sets. This multiple set sort is much more complex than a typical binary sort because more than two sets may be produced, and the attributes that define the type of sort are not opposites of one another and leads to an even deeper understanding of comparison. Understanding more and less is a bit more difficult when the items in the set are of very different sizes or shapes, such as this one. Do we have more raisins or more pizza? Or this one, are there more elephants or mice? These ideas are difficult for children and take teachers being really intentional with help and clarification to point out that there are different ways to figure out more depending upon the kind of question you're asking. Creating a classroom that can support conversations about these concepts takes time, but is extremely valuable for solidifying the ideas children have about both sets and counting. For many of you, when you hear the word data analysis, you think complex charts, graphs, computers. It may feel like it is a very strange thing to talk about with pre-K children, but it is something you all do, asking questions and finding answers, and can be very simple to help you gather information in a quantitative way and organize it in some way that makes a comparison and generalization possible in such a way that young children can understand. Think about it. Data allows us to create a new picture or a story about information, one that emphasizes some kind of measurement, such as a cardinal amount, and that shows or tells the information more efficiently, creating a simpler but more powerful set of ideas. We learn something new. Data analysis in pre-K can be very simple, making a list of items or writing down how many you have of each. Many of you check the weather with your children, so take it a step further. Create a bar graph of how many sunny days and how many rainy days you have in a month. The most important thing children can learn about data analysis is why we do it. When children see that the purpose of collecting data is to answer questions, they understand why data analysis is useful. That motivates children to try it and to understand how it works. And we often overlook that in order for children to experience authentic problem solving, they must be presented with an authentic problem to be solved. As adults, it is hard for us to break problems into those discrete steps that will help young children construct their own understanding. So take this for example. How many of you have a lost and found tub in your room? At this part of the year, it might include things like mittens, hats, jackets. It might also be a toy tub with those extra puzzle pieces and counters. Encourage children to mathematize the mess naturally, and that lends itself to sorting and quantifying, key activities for an inventory that form data analysis. Ask children to help you sort out your problem. You have introduced sorting and patterning, and this pushes their thinking into issues of data. After you pose the problem, encourage children to explore and propose solutions and try things out. In many ways, opening problem solving up to young children is not terribly efficient, but by helping them come up with a step-by-step approach and encouraging the use of trial and error, children will develop habits of asking questions around data. If data is predictable and obvious, they really aren't learning problem solving. But by posing questions such as, can you think why the mittens get lost more often? Or what type of clothes take up the most room in our box? Why? You are encouraging authentic problem solving. And with your thoughtful guidance and scaffolding, children can follow the steps involved in a simple data analysis process. When they have several different experiences under their belt, meant to answer different types of questions, they begin to see data must be represented in order to be interpreted, and how data is gathered and organized depends on the question. This makes children feel powerful and prepared to take action to understand their world. One of the first steps when helping children understand that data must be represented is having them make direct comparisons. This can be accomplished in many ways, and many of you are doing this in your classroom already. When you model and do think alouds, and when you are dealing with everyday tasks, you are turning those tasks into data discussions. When you show data in different ways, children will understand that there are clear ways to compare quantities of items or how many more. Teach children that now that we've counted in different ways, we can also use different ways to represent the data from our lunch count. The emphasis is not on collecting the data, but really getting children to think about the data. Comment about the results and what they show. This will lead to more questions and conversations. And with meaningful experiences and those thoughtful conversations, children will discover that even when we express our preferences, we can each have a good reason for preferring what we do and learn to listen to others' perspectives. Remember, the rule of thumb should be you spend twice as much time talking about the data as you do collecting the data. This book is a really good example to think about the steps involved in data analysis. First, we can sort in different ways, count the collections, then compare and represent the data in many different ways. Let's take a look at just a few pages from this book, How Many Snails? A Counting Book by Paul Gigante Jr. and Donald Cruz. I went walking and I wondered, how many clouds were there? How many clouds were big and fluffy? How many clouds were big and fluffy and gray? I went walking to the meadow and I wondered, how many flowers were there? How many flowers were yellow? How many flowers were yellow with black centers? I went walking to the lake and I wondered, how many fish were there? How many fish were red? How many fish were red and had their mouths open? I went walking to the garden and I wondered, how many snails were there? How many snails had striped shells? How many snails had striped shells and stuck their heads out? I went walking to the park and I wondered, how many dogs were there? How many dogs were spotted? How many dogs were spotted and had their tongues out? I went walking to the toy store and I wondered, how many trucks were there? How many trucks were fire trucks? How many trucks were fire trucks and had ladders on them? Remember, we always come back to the purpose. We use data to learn something new, and this is what makes the entire process make sense to young children. For example, how many of you do a how do you get to school graph at the beginning of the year? Save that graph and then later in the year revisit the graph with children. It may be now that the weather is cooler, not as many children walk to school. Do the graph again and compare those results. This helps make data usable to children. Collecting data about real-life issues to use to answer a question and help solve a problem is very powerful to young children. Focusing on surveys and inventories that aid in fact-finding can actively give ownership of a problem situation and its solution for children. Children need to understand that their choice isn't wrong. The data just shows that another one is the one chosen more often. Let's go back for just a moment to the lost and found example we looked at earlier. Using a situation such as this engages children in higher order thinking and puts the focus on the discussion and analysis of the results rather than just the collection of lost and found items and the collection of that data. While it might be more efficient in your classroom just to have parents go through that lost and found box or have children claim their own belongings, you can use this real life situation to really have children be more effective with problem solving. Once the problem has been identified and you have figured out what kind of data to collect, the method used to collect it emerges naturally. It is what we call mathematizing data, and it takes place in these 3 steps. But remember, sometimes data is not always clear cut, meaning the data can be easily sorted and inventoried. Sometimes you need to conduct a survey in which responses to a set of questions are compiled and analyzed. Connect surveys to the classroom investigations and surveys that support the homeschool connection. For example, you may talk about families. Who has families that live close by? How many of you have families that live far away? And you turn this lesson into learning about the different kinds of families. Or you often ask children where they like to go on vacation. You may ask, how many of you like to go to the beach? How many of you like to go camping? Take that survey a step further with camping and say, how many of you stay in a camper versus a tent? As you do this, lots of new questions will come up that help take the data to a deeper level. In pre-K, we actually use 2 types of surveys. We use fact-finding surveys, and this involves doing inventory of classroom materials, such as how many stuffed animals do we have? Then taking those stuffed animals and figuring out how many of each type of stuffed animals. Then you compare, how does this compare to the plastic animals in our classroom? Break that down. How does that compare to just dinosaurs? How does that compare to our baby dolls? And it refers to different ways of doing things. How many of you brush your teeth before you put on your pajamas? How many of you put on your pajamas before you brush your teeth? The other type of survey we use in pre-K is a preference survey, and it means just that, selecting or voting on options to indicate what children prefer. For preference surveys to be meaningful, children need to establish the habit of mind that data calls for analysis. This helps to ensure that surveys that examine preferences will be less likely to be seen as a contest, but rather children learn to appreciate that preferring one thing over another is not right or wrong because we all have unique opinions. Create ways to make data collection more dynamic by exploring that data in different ways. Many of you do attendance charts in your classrooms. Who is here today? Who is not? But now think of different ways to tally. For example, take attendance by who is wearing sneakers versus other types of shoes. Children will discover that even though we look at the data differently, we still come up with the same conclusion. The number of children wearing sneakers versus the other types of shoes is still equal to the total number of children present at school. It is just represented in a different way. Speaking of shoes, think about the sorting shoes activity we talked about earlier and take it a step further. Use the sorting map to create a bar graph, the type of graph we often use in pre-K. Using the real shoes to graph, we create what is called an object graph. This is a very concrete example for children. But again, to deepen children's knowledge of problem solving, we want to move from an object graph to a pictograph, where they draw their shoe to graph. This transitions them to more of an abstract representation and helps them see a single set of data out of many categories. I hope you enjoyed learning more about sets and data analysis in this Math is Everywhere podcast.